Hello and welcome. In this tutorial, we're going to be looking at quadratic inequality. So before I continue, I'm assuming that you're already familiar with the concept of quadratic expression and also quadratic equation and also the concept of inequalities. So you are going to be joining these two concepts together, quadratic equation and also inequalities, to form quadratic inequalities. So how do we define quadratic inequalities? So a quadratic inequality is simply an equation in which one side is a quadratic polynomial and the other side is zero. So it can take, so note that one side we have a quadratic polynomial and the other side equals to zero. So it can take any of the following form. So to judge if an expression is a quadratic expression or not, if it's a quadratic inequality or not, it can take any of the following form. It can be in form of ax squared plus bx plus c greater than 0, or it can be in the form of ax squared plus bx plus c less than 0, a squared plus bx plus c greater than or equal to 0, and lastly it can take the form ax squared plus bx plus c less than or equal to 0. So any of equation that takes this form refers to as a quadratic inequality. So now we're going to be looking at examples on how to solve any of this equation whenever we have one in our problem sets. In the first example, we have to find the solution to this expression: x squared plus 2x minus 8 is less than or equal to 0. So we can say that this resembles a quadratic inequality of the last four. So we have x squared plus 2x minus 8 less than or equal to 0. So I'm going to be going over two different methods of solving this. So, and also we are going to be going through each of the steps one after the other. So as I mentioned earlier, you're already familiar with the concept of quadratic expression and also the concept of inequalities. So as you can see here, we have a quadratic expression here and we have an inequality expression here. So the first thing we have to do is to find the zeros. So the first thing we're going to do is to find the zeros of our quadratic expression. So we just simply have to equate the quadratic expression to 0. So x squared plus 2x minus 8 equals 0. So using any method of solving quadratic expression, we can find the zeros of this equation. So using the factorization method, I'm going to have x squared plus 4x minus 2x minus 8 equal to 0. So I factorize this out, and then I'm going to have x minus 2 and x plus 4 equal to 0. So where this is simply coming from is if you factorize this. So if you factorize the first expression, we are going to have x, which is common, and we have x plus 4 over here. And if you factorize this second expression, we are going to have negative 2 and the same thing inside the bracket, x plus 4. So we pick one out of the bracket. This gives us x minus 2 and x plus 4. So that's how we come about what we have here. So after factorizing this, we simply find the zeros of our expression, and here we are going to have x to be equal to 2 or x equal to negative 4. So we have the solution of the quadratic expression to be x equal to 2 or x equal to negative 4. So knowing that the root of the equations are 2 and negative 4 as we just solved, so we have a positive, and also we have a positive coefficient of x squared. So what we have here, we have a positive coefficient of x squared. We can simply say this is plus 1 x squared. Please take note of this. So we have that these are the roots of our expression. So these are the roots of the equation. Also the coefficient of x squared is positive. So let me quickly review some things under quadratic expression. So if you have a quadratic equation and the coefficient of ax squared is positive, meaning the coefficient of x squared is positive. So we're going to have our graph, which is going to be a cup-like parabola, something of this nature. And if you have the coefficient of x squared to be negative, so we're going to have a n-like parabola, something of this nature. So take note of this: in quadratic expression, whenever we have the positive coefficient of x squared, we have a graph of this nature, and if you have the negative coefficient of n squared, we have a graph of this nature. So knowing this, we can now use this principle to solve for our quadratic inequality. So from here, we know that our graph is going to be something of this nature. Let me redraw this. And since we have a positive coefficient of x squared, we are going to have a cup-like parabola. Something of this nature. And with this, we know that we have the root of our equation to be at this point and also at this point. So this is -4 according to our expression, and also this is 2. So this means that the curve divides the x-axis into 3 parts. So this part, we can say that the curve divides the x-axis into 3 parts. So here we have another part, and lastly we have this part. So this part, this is x less than -4, and the middle part is -4 less than x less than 2, and the last part, this is x greater than 2. So just by looking at this, we know that anything that falls to the left of -4 is actually less than -4. So here we have x less than -4, and everything that falls in between this range falls in the range -4 less than x less than 2, and anything that falls to the right of 2 is greater than 2. That's why we have these 3 parts: x less than -4, -4 less than x less than 2, and lastly x greater than 2. So, and since that the inequality contains a negative, a less than symbol, so if you check here, our inequality has a less than symbol. So we simply take all the region that is below the x-axis. So assuming we have a positive, assuming we have a greater than symbol, we're going to be picking the region above the x-axis. So whenever we have a less than or equal to symbol, we're going to be picking the region below the x-axis. And if you check, the region that falls below the x-axis, this is our x-axis. So the region that falls below the x-axis is this region, which is this part. So from this part, we can say that the solution is simply the range -4 less than x less than 2, because it's the region that falls below the x-axis, simply because we have a less than or equal to symbol. So simply we just have to put less than or equal to less than or equal to here, so to show we have a less than or equal to symbol, and that's how we can find the solution to our quadratic inequality. That's one of the steps that's one of the methods that you can use to find the solution of quadratic inequality. So check again. Note the first thing you have to do is to find the root of your equation, then sketch the parabola. If it's a positive x-axis, then it's going to be a cup-like structure, and if it's a negative x-axis, it's going to be a n-like parabola. So check if you're having greater than, you're going to pick the region above the x-axis, and if you're having less than or equal to, or yes, if you're having less than or equal to, you pick the region below the x-axis. If you're having greater than or equal to, you pick the region above the x-axis. So that's the first method. So let me just put this in. First method. So I'm going to be using another method, and as I find this to be quite easy to understand, I'm going to be drawing some tables to find the solution to the quadratic inequality. So this is method 2. Again, recall that the expression we have is x squared plus 2x minus 8 less than or equal to 0. And after factorizing, so also in this step, the first thing you have to do is to factorize to find the zeros of the quadratic expression. So after factorizing, we have x minus 2, x plus 4 equal to 0. So this is what we have. So now we are going to be using this factorized expression to find the solution to our quadratic inequality. So what we have to do is to draw a table. So at this point, we are going to have the factors. So x minus 2 and the second factor x plus 4. And then you are going to have the product of the factors, so which is what we have here, x minus 2, x plus 4. So again, you draw, let's create another column. Maybe having 3 columns basically, and the last column. So we'll be using this. So from here we know that the zeros of our equation is simply x equal to 2 and or x equal to negative 4. So here you pick the smallest value out of the solutions we have for x, and then we have x to be equal to negative 4 to be the smallest value, and you simply assign a less than to it. So you're going to have x less than negative 4. S less than negative 4. The major principle behind that is simply what we have seen here. If you draw this parabola, we're going to see that x negative 4 comes before 2, and everything to the left of negative 4 is simply x less than negative 4. So pick the smallest value. All of the time you're going to be picking the smallest value first. So pick the smallest value and assign less than to it. So here we have x less than negative 4, and here we have minus 4 less than x less than 2, and lastly x greater than 2. So you have seen how we've come about all these ranges. X less than negative 4, this falls to the middle and this falls to the right hand side. So after that, you're going to pick a value that satisfies each of these range. So for example, the first range, which is x less than negative 4, you can pick negative 5, because negative 5 is less than negative 4. And also pick any value that satisfies this range. So you can pick one. So make sure you're picking the smallest thing that you can easily work with at any point in time. And x greater than 2, we can pick 3a, which is the immediate number after 2. So after picking that, so try to substitute each of these values to the expression we have at the left hand side. So meaning that if I substitute negative 5 minus 2, I'm going to have a negative answer. So if I have negative 5 minus 2, so substitute x to be equal to negative 5, I have negative 7. And since my answer is negatives, I just need to pick the negative and bring it here. Again, substitute negative 5 to the second factor, which is negative 5 plus 4. And also I'm going to have a negative answer, which is negative 1. I put negative a. So since this is the product of this factor and this factor, so you simply multiply the two signs together. So if you multiply negative and negative, you're going to have positive. The same thing we are going to pick for the second range. So I'm going to substitute 1 into this expression, x minus 2. So 1 minus 2 is going to be a negative 1. So we have a negative answer. So again, if I put 1 here, I'm going to have 1 plus 4, that's positive 5. And I have positive here. So if I multiply negative and positive, I'm going to have negative. So and lastly, substitute 3 into this expression. So if I substitute 3 into this expression, I'm going to have 3 minus 2, and that is 1, positive 1. Again, 3 plus 4 is going to be 7, and that is positive 7. And if I multiply positive and positive, I'm going to have positive again. So now, just like I discussed the other time, so whenever we have less than, or you have less than or equal to, so you simply go for, this is mapped to negative. And whenever you have greater than or equal to, this is mapped to positive. So if I check the question, what I have here is less than or equal to. So therefore I'm going to look for the answers that has a negative product. So which is simply this range, because this is the answer. So I have a negative answer here. So and the range that gives me a negative answer is simply the middle range. So which is simply negative 4 less than x less than 2. And again I have the solution to my quadratic inequality here. So that's simply how we can get the solution to our quadratic inequality. So you have seen how you can use the first method from the intuition and also the second method using the table. So with this, I'm sure you understand how to calculate the quadratic inequality. But there's quite much more to this and quite much more different use cases that you can see. So we are going to look at another example. Again, to look at another example, okay, let me create some real estate to work with here. Okay. So we have another example to solve the quadratic inequality negative x squared plus 4x minus 4 greater than or equal to 0. So as you're looking at this expression for the first time, the first thing you have to note is that the coefficient of x squared in this case is negative. So this has some influence on the nature of answer that we get. But first, let's find the root of the quadratic expression, which is simply to find the zeros of the quadratic expression. So writing out the quadratic equation, we have negative x squared plus 4x minus 4 equal to 0. So to make this much more easier for us to work with, I will simply take the left hand side to the right hand side so that we are going to have a positive x-axis. So we have x squared minus 4x plus 4 equal to 0. And now I can easily factorize this by saying this is x squared minus 2x minus 2x plus 4 equal to 0. So factorizing this, so x is going to go in both expressions, and this is x minus 2. The same thing here, I'm going to have negative 2, and this is x minus 2 again. So I have x minus 2 equal to 0. So here I have real and equal roots and x equal to 2 twice. So here I have real and equal roots, x equal to 2 twice. So if I try to sketch the graph of this expression, I'm going to have something of this nature. And since the coefficient of x squared is negative, so be sure that I'm going to have an n-like parabola. So and since the root is 2, if I have 2 here, so I know that the lowest point on this curve is simply 2, and it only causes, so the curve only touches the x-axis in one place, which is at the point 2. So meaning that we have x equal to 2 twice as our solution. So in this case, there is exactly one intercept, and the solution is x equal to 2. So if you want to write the solution in form of set, we can simply say that we have the solution in form of set. This is a singleton set. A singleton set. So invariably, whenever I have real and equal roots, so the solution to the quadratic inequality is going to be x equal to that particular root, which is 2. So we have the solution to the inequality to be x equal to 2. So that's simply how we can go about having real and equal roots under quadratic inequality. So now we are going to be looking at the last example, which is example number 3. So straightforward, in this example we simply have the factorized quadratic expression, and the factors are x minus 3 and x plus 2 greater than 0. I'm going to find the solution to this quadratic inequality. So again, the first thing we have to find is to find the zeros. So our work has been reduced for us in that we have the factorized expression already. So to find the zeros of this quadratic equation, we simply equate each of the factors to 0. So we are going to have x equal to 3 or x equal to -2. So we now have x equal to 3 and x equal to -2. So again, I'm going to be using the two methods that we looked at. So the first method, let's try to find the answer to this by intuition. So if I draw out the graph, and since I have the coefficient of, from here we know that the coefficient of x2 is going to be positive, because if you try to open this bracket, we're going to have x to multiply by x, and we're going to have x squared. So meaning that the coefficient of x squared is positive, so we're going to have an n-like parabola, a u-like parabola, sorry. So it can be something of this nature. And here we have the roots of our quadratic expression. So this is going to be -2, which is the low point, and this is going to be 3. So again, we have that this curve divides the x-axis into 3 different parts. So the first part is this part, the second part is this, and the third part is this. So in the first part, we have everything to the left of -2, and this is x less than -2. So for the middle part, we have it in between -2 and 3, and this is -2 less than x less than 3. And for the last part, we have x greater than 3. So in our symbol, we have greater than a. So I mentioned whenever we have greater than, you have to associate with it positive. So you have to look at all the points that falls above the x-axis. And if you look here, we have this particular range that falls above the x-axis, and also this range that falls above the x-axis. So here we are going to see that the solution to our quadratic inequality is simply x less than -2 or x greater than 3. It's supposed to be and. Sorry. Oh. So we are going to have the solution to be x less than -2 or x greater than 3. So take note again, just like I have explained, whenever we have greater than, you simply look at the points, the ranges above the x-axis. And whenever you're looking at less than, just like in the case of the first example, you look at the points below the x-axis. So again, they're going to be using the other formula, other method, which is the table method. So again, just like we have seen in the first example, so we're going to write out our factors, and in this case we have x less than x minus 3, x plus 2, and the product of x minus 3 and x plus 2. This is method 2. So at this first column, we're going to have x less than the smallest number, which is here x less than -2. So here we have x less than -2. So we have -2 less than x less than 3, and here we have x greater than 3. So take note, it's always going to be in this format whenever you are using this method. X less than the smallest number less than x less than the biggest number, and x greater than the biggest number. So we are going to pick any value that satisfies this range, and then we can pick -3. So again, we can pick 1 here, and then we can pick 4. So don't forget to pick the number that will be most convenient for you to work with. So if I substitute -3 into the first expression, we are going to have -3 minus -3, and that's going to be a -9, 6 negative answer. Again, if I substitute -3 into x plus 2, I'm going to have -3 plus 2. Also, I'm going to have a negative answer. And if I find the product of negative and negative, this is going to be positive. So for the second column, if I substitute 1, I'm going to have 1 minus 3. That's going to be -2, a negative answer. And if I substitute 1 plus 2, I'm going to have +3. That's positive answer. So negative multiplied by the positive, this is negative. And lastly, if I substitute 4 into x minus 3, I'm going to have 4 minus 3. That is positive. And again, 4 plus 2 is going to be 6, and that is positive. And find the product of positive and positive, this is going to be positive. So you can see here that we have two positive answers, and since we are looking at greater than, as I mentioned, we map greater than to positive and less than to negative. So I'm going to pick positive. But since in this case we have two positive, we're going to pick the two positive, this positive and this positive. So meaning that we're going to have, again in this case, our solution to be x less than -2 or x greater than 3. And then we have the solution to this quadratic inequality. So that's simply how we can find our way around solving quadratic inequality using the two different methods: by drawing the graph, finding the solution from intuition by drawing the graph, or using the tabular method. So don't forget to, if you find this tutorial useful at all, to give it a thumbs up and also subscribe to the channel. And if you have any question, you can always drop it in the comment section below, and I will try to reply to it as soon as possible. So that's it. Don't forget to subscribe before we go, and I'll see you in the next tutorial.